Question 6, financial maths. Okay, let's start at 6.1. Patrick deposited an amount of 18,500 Rand into an account earning R% interest per annum, compounded monthly. After 6 months, his balance was that. Calculate the value of R. Okay, so just a basic compound interest formula question. So 6.1.1, A equals P, 1 plus I to the power of N. Okay, let me rather say that it would be I over M to the power of N times M. Okay, because that is now when our compound interest is being compounded in a certain way. So now we've got A, which is his balance. So therefore A is 19,319,48 equals P, which is my principal value, starting amount, 18,500. 1 plus R%, which is what I'm trying to work out, over M, compounded monthly, so my M is 12, to the power of 6 months. So is there a reason for me to times this by 12? No, because the N is already in months, and that is how my interest is being applied. So there is no reason to put this times this by 12 because it is already months. Okay, the only reason why we times this by M is to make the years into however the interest is being applied. Okay, cool. So now that I have that, it's a matter of making R the subject of the formula. So we are going to divide both sides first by 18,500. And that is equal to 1 plus R% over 12 to the power of 6. We are then going to sixth root both sides. So sixth root, and that is going to leave me with, I'm only doing it for explanation purposes, guys. You don't have to put this much steps in, okay? But this is just for my method and what I'm doing. 1 plus R% over 12. We're then going to minus 1 from both sides. So we have the sixth root of 19,319 Rand and 48 cents all over 18,500 minus 1 equals R% over 12. Notice how I have not touched my calculator yet. Huh? The less calculator you use, the better here, because the more you use it, the more room for error, typing in zeros wrong, and so on and so forth. Now we're going to times the whole thing by 12. Okay, so only now, after I've done this and I've now established that R is by itself on the equal side, I can now use my calculator. Okay, so now that I'm going to use my calculator, let's have a look what the answer is. The calculator has given me an answer of 0,08700 reoccurring equals R%. Therefore, R is going to equal, so obviously to make it a percentage or to get the percentage away, we times it by 100. So then we're going to give it as 8.7% is my R value. Okay. Fantastic. Like I said, a lot of steps I added there. You did not really have to do all of those, but I was doing it for explanation purposes. Okay, let's just move that across so we have enough space for 6.1.2. Calculate the effective interest rate. Now, the effective interest rate is obviously using the formula 1 plus I nominal over M to the power of M. Okay, so we have a nominal interest rate. What is the difference between nominal and effective, everybody? A effective interest rate will always be only a per annum interest rate, whereas a nominal interest rate will always be per annum compounded in a certain way. So we're trying to change it from a compounded in a certain way into a yearly one, effective. Okay, so therefore, I effective equals 1 plus my nominal interest rate, which I have as 8.7% over 12 to the 12, minus 1. Notice how I've brought that 1 over, hey? Therefore, I effective equals that in my calculator, and it'll give me 0,09055 reoccurring, okay? And we make that into a percentage by timesing it by 100. So the effective interest rate is 9.06% if I rounded it up to 2 decimal places. A lot of people ask me questions about this and about this. James, why don't you change it into a decimal? I also feel like there is a lot more room for error there as well, because it'll be 0.087, whereas you've got a percentage button on your calculator, so you might as well use it, and then you're putting it in straight from the question, which doesn't give you actual room for error because you're not changing it into a decimal. It's just an additional calculation that you don't really need to use. Okay, fantastic, guys. That is question 6.1 finished. Great. Now on to 6.2. Let's have a look and see what we've got. Let's actually do it down here on a new page. Okay. Kuda bought a laptop of 10,000 Rand on the 31st of January 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. The value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. Okay, after how many years will the laptop have a value of 0? Okay, so we are dealing with depreciation. Different formulas here. So straight line depreciation means that it is D equals P1 minus IN. So it's basically the simple interest version of depreciation. Notice the negative as well, please. Okay. So the value of it, we want to know after how many years will it get a value of 0. So therefore its depreciated value is 0. It is starting at a value of 10,000. 1 minus I. What is the percentage? Depreciation is 20% times by n, which is what we're solving for. So therefore 0 equals 10,000, so we can times it in, so it's going to be 10,000 minus 10,000 times by 20% n, basically. So therefore we can bring that over. Let's also convert that. I'd actually do that in that step, to be honest. So let's change that into 20 over 100. 20 over 100. So we can now bring that over. So therefore, 10,000 times by 20 over 100 n equals 10,000. Okay. Divide both sides by 10,000. So 20 over 100 n equals 1. And then divide both sides by 20 over 100, which gives you n equals 100 over 20, which equals 5 years. Okay, not too bad, just a bit of algebra. Okay, then 6.2.2. Kudu will buy a laptop that costs 20,000 Rand. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of February 2019. He will make his 60th monthly deposit on 31st of January 2024. The savings account pays interest at 8.7% per annum compounded monthly. Calculate Kudu's monthly deposit into his account. Okay, so he is now saving up for this, which means he is using a future value annuity. Okay. So a future value annuity means, what is the definition of an annuity, guys? Equal payments made at equal intervals of time, either to pay off a loan, present value, or to save a lump sum of money in the future, which is future value annuity. Okay, so he will buy one that costs 20,000, so that's how much we want. In order to cover the costs, he makes his first monthly pay deposit 28th of February 2019. Okay, so he starts 1 month after, which everything seems to be normal. Okay, so timeline wise, when you make your first payment 1 month after you've opened up your account or whatever you're doing, that is normal in normal senses. You do not have to add 1 to n or anything like that. It's when your payments into these certain things are made immediately is where you would need to add 1 to n. Okay, so we now have our future value that we want is 20,000. That's how much we want in the bank. X, we don't know what the deposit is every month. That's what we're trying to solve for. And we are using the future value formula X open square bracket 1 plus I to the n minus 1, close square bracket all over I. That is your future value annuity formula. You do get that on the formula sheet. Okay. Once we have that, we can then say 1 plus, we're getting an 8.7%. And is it compounded monthly? Yes, it is. So we can put that over 12. Let me rather rewrite that and put that over 12. Okay, so we're going to say 8.7% over 12 to the power of, it's going to be 5 years, so 5 times 12, so 60 payments minus 1, all over 8.7% over 12. Okay, therefore 20,000. Again, we do not touch our calculator until we have x by itself, all over, and I'm bringing this over 1 plus 8.7% over 12 to the power of 60 minus 1 equals x. Therefore, x is going to equal, and we can put that in our calculator and it'll give us 267 Rand and 26 cents. That's how much he would have to put away monthly in order to have 20,000 Rand saved up after 5 years. Okay, and that is 6.2.2. Let's have a look at 6.3. Tino wins a jackpot of 1.6 million. He invests all of his winnings in a fund that earns interest at that compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from his fund? Okay, so this is an example of a, believe it or not, present value annuity. A lot of people link loans with present value and investments with future value. Yes, this is an investment because he is putting it away. But I need you guys to understand that the formulas work like this. A future value formula or future value means a big amount, small amounts being put away. Small amounts put away. So in future, you have a large amount. Okay, now the present value is paying off. So you get presently, you have a large amount, and your small amounts decrease the large amount. Okay, sounds pretty weird, but that's kind of how we are going to be doing this. Future value deals with, in the future, I'm going to have a big amount. Present value, currently I have a big amount and it is decreasing over time. So this is present value because he's got 1.6 million, right? And he's going to be taking 20,000 out of that 1.6 million every single month, which means what? It means that that 1.6 is going to slowly decrease over time because he is taking money away from it. So present value annuity here is definitely the one that we are going to use. So presently he has, so present value annuity formula is very similar to the future value, but we're just switching and we're making our N negative. Okay, so presently I have 1.6 million. I'm taking out 20,000 each month. 1 minus 1 plus, what is the interest rate I'm getting here? 11.2% monthly to the power of minus n, which I'm trying to figure out, all over 11.2% over 12. Okay, so now we are going to get n to be the subject of the formula. So I'm going to say 1.6 million, 1, 2, 3, is timesing by the denominator, getting divided by the 20,000 equals 1 minus 1 plus 11.2% over 12 to the power of minus n. Let's bring that one over. 1.6 million, 11.2% over 12, all over 20,000, minus 1 equals minus 1 plus 11.2% over 12 Okay, only now would I allow you to use your calculator and make this left-hand side a decimal. So let's put that into the calculator quickly, and it gives me minus 19 over 75, minus 19 over 7. There's a reason why I'm keeping it the fraction, is because it's a lot easier to write. Okay, I'm not going to write a long decimal that goes for days. So I'm going to do that. Then what's going to happen to the negatives, guys? The negatives will cancel. Now, how do I get the exponent, the unknown out of the exponent? We use logs. Okay, so we are going to use our, what is the formula? B to the C equals A, log B A equals C. Remember, from exponential form into log form, okay? And you can go both ways. So at the moment, it's an exponential form. So if I want to label it, I can say that this is my A, this is my B, and this is my C. And let's do the conversion. Therefore, minus n equals B, which is log of 1 plus 11,2% over 12 by 19 over 75. Therefore, minus n equals, let's see on the calculator, and it gives me minus 147,797 reoccurring. Okay, and then the negatives would fall away. And let's just see what the question is asking me. It says, how many withdrawals of 20,000 will he be able to make? Well, this is telling me that if these are months, he makes a withdrawal every month, right? So he'll be able to make 147 full 20,000 Rand withdrawals. Because the other one, or the 0.797, isn't a full number, it won't be a full value of 20,000. He won't have enough to make another full withdrawal of 20,000. Okay, so my final answer is 147 withdrawals. Okay, great, guys. That is financial maths done. Nothing too tricky about that. They didn't load this paper with that, so that was actually quite nice.